Hi everyone, welcome back to Art of the Part. In this video, I'm going to show you how to create a complex second operation program in MasterCam using the 3D model of the Softriser A-1 that we imported from SOLIDWORKS. In the last video, we finished first operation, and that was more or less an introduction to MasterCam and how to use the 2D toolpath gallery. And if I expand out this gallery at the top left, we looked at the face mill, the contour, the drill, as well as the model chamfer, the chamfer drill, and the circle mill. And all of those toolpaths are out here on the left-hand side in my Operations Manager. I can also see those toolpaths here in my viewport, all those different lines. And if I want to see what that finished result looks like, I'm going to go up here at the top left in the Toolpaths window, and I'm going to click on that half-pipe looking icon for Verify. And we can see what those toolpaths will look like as they cut against the stock material. So when I hit play, we can see our face mill as well as our contour. And then we hit these 4 drilled holes, and now we're opening up the 2 oversized holes with circle mill. We'll clean up the outside edge with a chamfer mill and then a chamfer drill on each one of these holes, and then we engrave the Softriser A-1 at the center of the part. And that's going to complete first operation. So as we move into second operation, I actually want to use this finished model here from Verify as my stock material. And that's because when we're in second operation, we're eventually going to reach the depths or the extents of our contour mill as well as some of these holes. And now we're starting to get into this theory of multi-op programming, and that's going to be useful as you start to get out in industry. So let's go ahead and back out of Verify and get started here in second operation. So let's begin by cleaning up our Operation Manager. That way we can make some room for our second operation toolpath. So over here on the left-hand side in my Operation Manager, all I'm going to do is just hit the minus button next to each one of my toolpath operations. So here next to facing, there's a minus button. We'll click on that, and that's just going to compress that folder down. We're going to continue, and we'll hit that next to contour, drill, circle mill, model chamfer, chamfer drill, and contour. We can also simply just minimize this entire folder here, so that toolpath group 1, I can hit the minus button next to that. However, that just hides all your toolpaths, so you won't be able to make any changes unless you expand out that folder once again. So if you want to see them, you just have to hit the plus button next to toolpath group 1, and that's going to bring back all of your toolpaths. So now that we've made some room in our Operation Manager, let's create a secondary toolpath group for second operation. Now, you have to be careful what you currently have selected. So for example, right now I have my toolpath group 1 selected. If I create another toolpath group, it's just going to place that within this folder. And you want to keep those two programs separate. So the best way to do this is to come up here to our machine group 1, click on machine group 1, have that selected, right click on machine group 1, and then come down here to groups, and then you just want to add a new toolpath group. If you add a new machine group, that's going to add another machine. We want to stay within that machine so that we can maintain our tool library and our stock material. So go down here to new toolpath group, and you'll see that will populate a toolpath group 2 beneath that toolpath group 1. Now, toolpath group 2 is currently highlighted. It's allowing me to do a text change or a rename. So I'm just going to title this second operation. And we can do the same thing here to toolpath group 1. All we have to do is click, wait, and click again, and that allows me to open up that text edit box. So I'll click, wait, click again, and now I can rename this first operation. So now we can clearly see what's first operation and what's second operation. So let's go ahead and click on our second operation toolpath group, and I want to make sure that our red arrow is beneath this so that any new toolpaths are going to be created in this folder. Now, when we look at these two operations, they're both beneath the machine group 1, which means that they're driving from the same stock setup that we created for first operation. However, for second operation, I want to see that finished verified model that we were looking at earlier after all of these toolpaths. So let's jump over here into our top ribbon bar and find our Toolpaths tab. And inside of Toolpaths, I want you to look for an icon called Stock Model. And it's going to be located here in the Stock section, right next to Stock Display, and it's this gray half-pipe looking icon called Stock Model. We'll click on that, and it's going to open up the stock model window. And beneath the window, we can actually see in our Operations Manager that we're trying to create a stock model for second operation. So back in the window, let's rename that stock model First Op Finish. And then we can associate a color to the mesh file that we're creating so that it's a little bit easier to see our toolpaths and verify. So over here to the right where it says color, it's currently set to gray. There's a color palette here. If we click on that, it's going to open up this window. And I like using something nice and bright so I can see those toolpaths and verify. So I'm just going to click on this pink color right here and then hit the green check mark. And then we're going to work our way down, and we're currently working from the stock plane first op top, and that's correct because we want to be pulling from that top plane that we set up for first operation so that all of our toolpaths are going to run against that plane. And as we continue to go down, it's asking what we want to use for a reference stock material. We've already set that up here in Machine Group 1 where it says Stock Setup, so let's go ahead and click Stock Setup right here. And when we click on Stock Setup, it'll actually match up our X, Y, and Z extents. So now that we've established our stock definition, we're going to jump down one tab here into Source Operations. And inside of Source Operations, all we're trying to do is tell the stock material what toolpaths do we want to run against it so that we can create that mesh file. So over here, we're just going to select our first operation toolpath group, and we can see that all of our toolpath has been selected. There's a check mark next to each one of these toolpaths. And then when I hit the green check mark, it's going to create that mesh file that we can use as the stock material for second operation. Now, if you're working in MasterCam 2024 and up, you don't have to reassociate your stock material every time you create one. The software will simply recognize that anytime you have a stock model in your operations manager, it's going to be used in Verify while you try to simulate your toolpath later. However, if we're working in MasterCam 2023 and down, you will need to reassociate any stock model that you want to use in Verify under the simulator options. So on the left-hand side in our operations manager, we're going to go to the top of the window and find the icon with three little waves and a gear in the corner of it. It's actually just to the right of our Verify icon. So click on Simulator Options, and this is going to open up our Simulator Options window, and by default, we're always going to be pulling from the stock setup to be used in Verify. We just want to relink this to that stock model that we created for that first op finish, so just go down here to the bottom, and we're going to click on Stock Model, and we can look for the first op finish or hit the drop down menu, and you can choose from any other stock models that you created. We'll hit the green check mark, and now when we create toolpath, this is going to be used whenever we hit Verify. So now that I have everything I need from first operation, let's go ahead and create a new plane for second operation so that all of my toolpath will run perpendicular to the front side of the part. However, I really can't see any of that geometry right now because it's being hidden by the stock model that we just created. So what we need to do is go over here to the left-hand side in our operations manager, and you'll notice that your stock model, the one that we just created, will operate just like toolpath geometry. So we just want to make sure that we have it selected and that there's a check mark next to the stock model. And then we're going to move to the top of that window, and we're going to find those three waves to toggle the display to selected operations. So if I click on these three waves, it'll actually let me turn my stock model on or off. So I just want to turn that stock model off, and that way I can see the top side of my part and create that plane for second operation. So let's jump down here into the bottom left of our operations manager, and we're currently here in the toolpaths tab, and we're going to head over to the right into the planes tab. So click on that planes tab, and we're going to do the exact same thing that we did for first operation, where we create a dynamic plane and we attach it to the top edge, and then we rotate that around so that Z is pointing up. So up here in the top left-hand corner where it says planes, right underneath that, I'm going to hit the green plus button, expand out this menu, and find that dynamic option. You'll notice that we'll have that gnomon attached to our mouse now, and I might have to zoom into my part, but I want to line this up with the inside edge of that blind hole at the center of our component. So I'll click on that edge there, and then we are going to rotate this around so that Z is pointing up, which means we have to rotate around the X or the A axis. So I'll click on any one of these red segments, and then I want to stay inside this wheel here so that I get to 180 degrees so that Z is pointing directly up. So I'll click right there, and then we're going to name this plane over here on the left-hand side, second op top. And we'll hit the green check mark, and that's going to bring us back out here into our planes tab, and we just want to make sure that our WCS and our C&T planes are all linked to that new plane that we created for the second op top. So right now they're still linked to the first op top from first operation. So here inside these columns and rows, I'm just going to link the WCS here to second op top, as well as the C and the T plane to second op top. So let's jump back into our Toolpaths tab in the bottom left of our Operation Manager. So right now we're in that Planes tab. We're going to go over here to the left, and we're going to find the Toolpaths tab. And the first toolpath operation that we're going to take a look at is a face mill so we can clean up the top edge of this part. So here inside of our 2D gallery, we can either expand this out or click here from the top row. We're going to find that face mill. So click on face mill, and we're going to treat this exactly like we did for the first operation. So I'm going to zoom out a little bit so I can see my part a little bit better. And I'm going to change this from solid chaining to wireframe chaining, and I can still pick up that wireframe that we had from first operation. So I'll click on this top edge here, and I can either click on the red arrow, or I can click the fast forward here for endpoint forward. Click, click, and I'll get a nice yellow box around that top edge. We'll hit the green check mark, and that's going to open up our parameters window. So we'll jump down here into our tool tab, and this is still pulling the same tool library that we were using for first operation because we're currently in the same machine group. So pick up that 3-inch face mill, and we'll just type a note here for 3-inch face mill. And then we'll jump down here into our cut parameters. And inside of cut parameters, it's still going to pull the same settings that we had for first operation. So our cutting method is going to be 1 pass. Exit and approach distance should be 25%. And the stock to leave on floors should be 0. We'll go down here to depth cuts. And again, we're still going to pick up those same settings. So it's going to be 10 thousandths max roughest step. And then we're going to keep that tool down. We'll go down here to linking parameters. Just make sure that each one of these are reading absolute, 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 and absolute. Top of stock, we can double check that, but it's 15 thousandths. If we click top of stock here, we can click on the top corner of our stock material. So we are getting that 15 thousandths. However, the depth should read 0 because we want to go to the top face of that plane that we just created, or the top edge of this part. So click on depth, and we just want to click on that inside edge or that top edge of the hole that's going through the center of the piece. So we'll click there. We can see that it's registering as 0, which matches the second op top plane that we just created. So a good double check for us, especially if you're moving from first operation to second operation in the same MasterCam file, is just to come down here into the planes tab, and here inside of planes, just make sure that everything is reading second op top, and second op top. And this is going to be your WCS, your T, and your C plane. And if you see first op top for any reason on any one of these, there's a chance that you could actually project the tool upside down in first operation, which wouldn't work for your second operation program. So let's go ahead and hit the green check mark. And we can see that the toolpath is being generated for that 3-inch face mill at the top of the part. So let's just confirm that we are still using the second op top plane to project these tools, as well as pulling from that first op finish that we created for the stock setup in Verify. So over here on the left hand side in our operations manager, we're going to go to the top of the window and look for that half pipe looking icon called Verify. We'll click on Verify, and this is going to open up that secondary window for us, and we can see that the first op finish, that stock model that we created, is now being simulated out here in the Verify window. And I just want to make sure that that tool is going to travel across the top of the piece. So we'll come down here and we'll hit play. And we can see that 3-inch face mill is going to cut across the top, and then it's going to come back. So I think it's safe to say that we set up everything correctly and that we have our second op top in the right orientation, as well as that first op finish for our stock material. So let's back out of here from Verify and we can continue programming. Now the next toolpath that I want to show you is one of my favorites in all of MasterCam. It's called 2D Dynamic Mill, and we can use this for intelligent metal removal for multiple different applications. So we're going to go over here to the top left-hand corner in our 2D toolpath gallery, and we can either pick from the top row or we can hit this drop-down menu, and we're going to look for this icon with the swirl and then a red arrow attached to it. So click on Dynamic Mill, and this is going to open up your chaining options, and this toolpath is going to work a lot like face mill and contour mill combined. So we can choose automatic regions. However, I want to show you how to set this up manually so you can use it for almost any application. So we're going to come down here to machining regions, and we're going to select this mouse button for select machining chains. And this is going to be the face mill section of this. And again, this is why I always set up my wireframe geometry to match the stock, because it makes toolpaths like this really easy. So here inside the chaining, make sure you are set to wireframe. We're going to choose the chains, and we're going to select this top edge. And we're just going to go around that top surface like a face mill until we see the entire top face selected there in yellow. We'll hit the green check mark, and now we have to set up our machine region strategy. So we have to tell the toolpath, do we want to stay inside that selection that we just made, or do we want to approach from the outside? So we don't have any geometry or details that we have to worry about, so I think we can approach this from the outside here. So we'll change this to from outside for our machine region strategy. And the last thing that we need to do is tell the tool what geometry should we avoid as we're cutting the selection. So we're going to come down here to avoidance regions, and we're going to select the avoidance regions chain, and this is going to operate a lot like 2D contour. So we're going to change it from wireframe over to solids, and we're going to deselect the face option, and we only want to select the loop. And we're just going to come over here to the top edge of this outside profile. We'll select on that, and we get the entire tangent loop. We'll hit the green check mark. And we've established what we're going to be cutting here in the machining regions, how we're going to be approaching that cut with the machine region strategy, and then what geometry do we need to avoid using avoidance regions. So as long as you have these 3 criteria set up, we can go ahead and hit the green check mark and move forward into our parameters window. And you can see we can make any changes from the right hand side as long as we're here inside of that toolpath type. So we're just going to jump down here into the Tool tab, and we're going to use the 5/8 flat end mill to cut the outside edge of this piece. So find your 292 tool, that's going to be your 5/8 flat end mill. We're going to leave ourselves a comment for a 0.625 end mill, and then we'll just say dynamic mill. And then we'll jump down here into our cut parameters tab. And inside of cut parameters, there's a whole lot of information. However, I just want you to focus on a few details. First, we're going to look at the stock to leave on walls and floor, and we're going to change this to 0. So we'll make this 0 and 0. And then we can look at our step over distance. Currently, this is set at 25%, so that just means that we're overlapping the tool 25% every time we make a cut. If you ever get into high-speed milling or HSM, you might calculate this out to be 7 or 10%, so just keep that in mind. And then I just want to talk about the back feed rate. Now, for whatever reason, I think this is just a glitch within 2D Dynamic Mill, but sometimes it can reset this value to like 0.0001, and that can cause your toolpath to just cut forever. So just make sure that if you see that maybe in your verify or in your backplot, come back here into the cut parameters and change your back feed rate to 100. Next, I want to talk about depth cuts. Now, whenever you're using 2D Dynamic Mill, you're really removing the need for depth cuts because you're accounting for it with your step over percentage. So the only time that you want to turn your depth cuts on is when you have a truly deep cut or a deep pocket. So in this particular example, we're only going about, like a ½ inch down. So we're going to leave depth cuts off. So all we need to do now is just come down here to our linking parameters. And inside of linking parameters, we're just going to treat this like we've done any other toolpath. Make sure that everything is set to absolute, 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 and absolute. Top of stock is going to be 0 now because we took that away with the face mill. So we'll change this top of stock to 0. We'll click on this top edge there. And the depth, it is recognizing that we are trying to go to negative 5.9375, but we can go ahead and check that by clicking on depth, and we can click on this bottom edge here. So we are getting that negative 0.59375 value. And let's go ahead and hit the green check mark. Now I can see that the 2D Dynamic Mill is creating some truly unique toolpath geometry. And that's all thanks to that intelligent material removal that I was talking about earlier. So let's see what this looks like in Verify. So I'll go over here in the left-hand side of my Operations Manager, and I'll go to the top of the window and find my half-pipe looking icon for Verify. This is going to open up that secondary window for us. We can see the first stop finish being used for the stock material of the simulation, and I'm just going to slow down my playback speed so I can talk about this toolpath as it's cutting. So I'll hit the play button here, and we can see as the tool is traveling around the part, we aren't just doing straight up and down cuts. We're actually entering and exiting the part at different depths. We can see that there are radii in some of these corners, and this is to optimize the cut in the most efficient way possible to improve the surface finish and increase the life of the tool. And that's the intelligent design behind the 2D Dynamic Mill. And then as this finishes, I want to compare the verified model against the 3D model that we brought in from SolidWorks because these cuts here in the corner are looking a little light. So here inside the Home tab, I'm going to go to Visibility, and I'm going to turn on my workpiece, which is going to be that 3D model, and then I'm going to toggle my stock so that it's transparent. And you can see that, yeah, it's not going as deep as I want to, so I actually need to come back and clean up those corners with a separate toolpath. So let's back out of Verify and look at that next toolpath. Now, the 2D Dynamic Mill worked very well for us. So I want to see if I can use that toolpath again to clean up these inside radii for both of these slots. However, instead of creating a brand new toolpath for 2D Dynamic Mill where I have to set up my machining regions, my cutting strategy, and my avoidance geometry, why don't we try and copy and paste our last toolpath and make some adjustments to our parameters. Now, I want you to select that 2D Dynamic Mill that we just created. It should be the last toolpath in our Operations Manager, and when you click on it or have it highlighted, there should be a check mark next to that toolpath and that toolpath only. And just double check this for me, but if you have a check mark next to any of these other toolpaths, when you go to copy and paste, you could end up doubling your entire Operations Manager, and that could be pretty bad. So just make sure again that we're selecting that last toolpath and that we have a check mark next to it, and once you have it highlighted, right click on it and it's going to open up this drop down menu for us. We're going to look for the copy command located right here. Click on copy, and that's going to copy that toolpath to our clipboard. And then as a good double check, make sure that your red arrow for inserting toolpath geometry is located at the bottom of your Operations Manager. And then right next to that red arrow, go ahead and right click, and then we're going to open up that drop down menu again, and we're going to look for the option for paste. So click on paste, and you can see that we created a secondary 2D Dynamic Mill. So let's expand out that toolpath that we just copied and pasted. So I'm going to hit the plus button next to the folder, and then we're going to look for the parameters option. So double click on parameters. It's going to open up that parameters window for us, and we're going to jump down here into our tool tab. And inside the tool tab, we can see that we're currently using the 5/8 flat end mill. And from the toolpath that's being generated out here, we're not reaching the bottom or the inside radius of this slot. So I think that this tool is just a little bit too big. So let's go ahead and change this from a 5/8 flat end mill to a 5/16 flat end mill. And when we click on that, we'll notice that the speeds and feeds does not update from one tool to the other. So we'll have to right click on that tool that we just selected, and then we have to reinitialize our speeds and feeds. So when you click on reinitialize speeds and feeds, it's going to recognize that it's a smaller tool, and it's going to increase those speeds and feeds for us. Now here in the comment, we just have to update this from a 5/8 flat end mill to a 0.312 or a 5/16 flat end mill. And before we make any other changes, let's see how this toolpath will regenerate using the new tool. So I'll come down here and hit my green check mark. I'll let that regenerate. And it looks like we are hitting the inside radii of both of those slots. However, we have all this extra toolpath that's now cutting air because that material's already been removed by the 2D dynamic mill before it. So how do I only focus on these slots and get rid of the extra toolpath that we no longer need? Well, one of my favorite parts about Dynamic Mill and other advanced toolpaths in MasterCam is our ability to define previously removed material. And this is as easy as just going into our parameters tab and just selecting a couple checkboxes. So let's go back over here into our operations manager on the left hand side, and beneath this 2D dynamic mill that we just copied and pasted, we'll click on that parameters. We'll open up the parameters window. We were looking at the tools, but I want you to just jump down here to the stock tab. And right now this should not be activated. There should be like a red circle with a cross through it. So select on your stock tab, and inside of that stock tab we have the rest material window. Now, the rest material window allows us to choose from existing toolpaths from our operation manager to be considered for the toolpath that we're currently creating. So we want to turn on rest material here. So there's a checkbox next to rest material. Select that, and it allows us to compute remaining stock from all previous operations, and we currently have all groups selected. However, if you hit the drop-down menu, we do have the ability to do toolpath group only, machine group only, or one other operation. Now, my experience is when you have all groups selected or the entire machine group selected, there's just too much information that has to be computed. So I like to only look at my toolpath group. So this is going to be our second operation. And here's the importance for us setting up a separate toolpath group for first operation and second operation. So we only want to do the toolpath group that we're currently in, and then we can hit the green check mark and see how this regenerates. Now, I don't know about you, but that looks like a massive improvement from what we were looking at earlier. We were able to get rid of all that geometry that was cutting air, and now we're just focusing on these two slots. So let's see what all this looks like in our verify. So we'll select our entire second operation. So that's also going to include that stock model that we set up. And then up at the top of the window of the operations manager, we're going to click on the half pipe looking icon for verify. And this is going to open up that secondary window for us. And this will have the same settings that we left off on, where our master 3D model, that workpiece, is currently turned on, and our stock is set up as transparent. So let's let this play out and see what happens. So I'll hit play. We did our face mill, that was our dynamic mill, and then we went in and added an additional dynamic mill to clean up these slots here. So you can see now we're cutting into that. However, as this is cutting, I do want to make mention of this. So I'm going to move my tool back here, slide this back, and I'll move it all the way back to this pocket here at the front. And I want to stop this, and I'm going to turn off my workpiece, and then I'm going to make my stock material fully opaque. So let's take a look at our tool here. This yellow surface that we're seeing is our available cutting length. And I don't know what that value is off the top of my head. However, I do know that the depth of this slot is roughly 593 thousandths because we set that up in our linking parameters. So we can see that we're getting pretty close to full tool engagement, which would lead me to believe that we should change our cutting strategy before we post out this program. So let's back out of verify and take a look at that tool. So let's jump over here into our operations manager and find that last 2D dynamic mill that we were working on. And just like how we could double click on parameters to open up that window, we can also double click on the tool that we're using. So if you see tool number 286 followed by 312 flat end mill, double click on that. And this is going to open up our edit tool window. Now, I don't want to make any changes here because these are the true values of that tool. However, I can see that there are dimensions for our cutting diameter, which is 312, my overall length, which is 2 inch 500, and my cutting length here, which is 750. And if I click on that, I can actually see that it's represented there in that yellow length. So think back to our verify example. Likewise, if we think about that 750 cutting length, we can also think about that depth cut, which was 593. And if we just do the math there, that's roughly 80% of our tool engagement. And in my opinion, I think that's just a little bit too much. So I just want to consider that or keep that in mind while I look at making some changes to my cutting strategy. So let's back out of the edit tool here, and then we can go ahead and jump back here into our parameters. Now, there are really only three options for me to consider if I want to continue using this toolpath. First, I can come up here into my tool, and I can either find a tool with more rigidity or use a bigger diameter. Second, I can go down here to my cut parameters, and if I want to do something like high-speed milling or HSM, I can use a little bit more conservative approach for my step over distance and change this to like 5 or 10%. Or third, I can come down here into my depth cuts, and I know I said I don't like using depth cuts for 2D dynamic mill. However, I think that this is going to be a great example of how to use containment regions to control our tool paths. So let's go ahead and turn on our depth cuts here, and we're going to change the max rough step to the diameter of our tool, which is going to be 0.312. So let's go ahead and hit the green check mark and see how this regenerates. Alright, so it looks like we were able to separate that toolpath into two depth passes, but now we've created this brown line that's traveling around the outside of the part, and it's leading in and leading out to each one of these slots. So I'm not really sure what that toolpath is going to look like, and instead of running a full-blown verify simulation, let's see what this looks like using our backplot selected operations. So over here on the left-hand side in our operations manager, make sure that you do have that 2D dynamic mill selected, and then we'll go to the top of the window and find those three little waves for backplot selected operations. Click on that icon, we can see that our tool is generated out there in our viewport, and from the top left we'll go ahead and hit play. So we can see that our tool is traveling to that 312 depth for this slot. However, instead of going down to the final Z pass, it's traveling around the outside of the part and doing the 312 depth on the opposite slot. And then we're going to retract out, and then we'll go to our final Z depth. We'll finish this slot here, and then once again, we're going to travel around the outside of the part and go to the final Z depth of this slot on the opposite side. Now, I'm sure you can imagine this is a lot of wasted time, and I want to try to optimize this cut using our containment regions. So we're going to back out of backplot and take a look at that detail. So I'm just going to jump back down here into my parameters of that 2D dynamic mill. It's going to open up our parameters window, and we're just going to jump up here to our toolpath type. So like I said earlier, we can make changes on the right-hand side of this window, and we just have to make one slight adjustment. Right down here near the bottom, we have containment regions. So click on this to select containment chains. And if we wanted to, we could set up like a wireframe to just contain both of these slots on their own. But I think just a really quick and easy fix is just making sure that we're here inside of the 3D or the solids chaining. And we'll do the solid loop, and we just want to grab this outside edge. We'll hit the green check mark, and then we'll hit the green check mark once again. And we can see that we've removed those brown lines that are traveling around the outside of the part. Likewise, we're attempting to contain the tool to finish one slot before moving over to the opposite side. So let's run this in backplot again to see what it looks like. So we'll move over here to the left-hand side in our operations manager. At the top of the window, we'll find those three little waves for backplot selected operations, and then we'll go and hit the play button from the top left of the window. We can see that the tool is traveling down to that 312 depth, but instead of going all the way around the outside of the part and trying to finish the 312 depth of this slot, we actually retracted out slightly and then came back down to the final Z depth and then finished this slot. Now we'll retract out, and then we're going to hit this slot at 312, and then once it's finished with this cut, it'll retract out, and then it'll go down to the final Z depth and then finish that slot. So I'm pretty happy with the changes we made, especially optimizing this toolpath to cut these two slots. So let's go ahead and back out of verify, and we can start to look at the next details, which are the circular faces, and then drilling and finishing the part. So now that we've learned to use 2D dynamic mill to great success, I'd like to continue to use that toolpath to machine away these circular steps. But before we create any toolpath geometry, I want you to start to think about your machining parameters. So for example, what's going to be your machining region, what's going to be your cutting approach, and what's going to be your avoidance geometry. So for this example, we could set up the outer extents of our stock material to be used for our machining regions. However, we would also have to set up our rest material to recognize that we did machine these details away. Likewise, we could use the outer extents of this surface and try to create one nice circular contained region, but we are going to be interrupted by these slots. So I think in this example, it's probably best just to create our own machine region geometry as a separate wireframe level. So let's just jump down here into the bottom tabs of our operations manager. So we're currently sitting here in toolpaths. we're going to jump over here to the Levels tab. Inside of Levels, we're just going to go up to the top left corner and we're going to find that plus button right beneath Levels. We'll click on that to add a new level. We'll double click on that level and we're going to name this Circle. All right, so we currently have 0 entities on that circle level. So we just want to add or create wireframe geometry. So up here in the top ribbon toolbar, we're currently in the Toolpaths tab. We're going to go all the way over here to the left and find wireframe. Click on wireframe, and I want you to find the circle center point icon. So we'll click on that circle center point icon. It's going to be asking where we want to drop the center point of the circle, and we can just make it coincident here with the center of this drilled hole. So we'll click once here, and then we're going to drag this circle out or move our mouse out, and we just want to make it coincident with the endpoint of one of these edges of the slot. So I'll click on one of these edges. That circle should match up 1-to-1 to that. We do see that it does have a diameter of 2.75, which is that value. So we'll hit the green check mark, and now we have one entity on that circle level. From here, we're just going to jump back down into our Toolpaths tab in the Operations Manager, as well as the Toolpaths tab in our top ribbon. So we'll go up here and we'll click on Toolpaths. So we should see Toolpaths and Toolpaths. We'll jump back into our 2D dynamic mill. We can either hit the drop down to expand out the gallery, but we're just trying to look for our dynamic mill option. Click on dynamic mill. We're going to select our machining regions. We'll select this chain, and we're going to toggle it back from solids over to wireframe. And then we just want to chain that circle that we just created. So that's going to be our machining regions. We are going to machine this from the outside. And now our avoidance region, we're just going to do this first step here. So we'll click avoidance region. We will have to toggle it back from wireframe over to solids. And we're going to turn off the face here, but we do want to be selecting from these loops. So I'll just jump down here to the top or outside edge of the circle. We'll select on that so that this will be our avoidance region. We'll hit the green check mark. And we've now set this up so our machining region is that outside wireframe circle we created. The machining region or the approach strategy here is going to be from the outside, and our avoidance region is going to be this center section here so that we don't cross over and cut through that hole. So we'll hit the green check mark, and then here we'll open up our parameters window. We'll jump down here into tools. We really don't have to worry about any geometry here, so I can use a bigger tool. We use the 5/8 flat end mill. I'll leave a note here for 0.625 end mill, and then we'll just say first circle. So we'll jump down here to our stock. While we can leave stock or rest material on, I do want to avoid recognizing these two slots here because we might jump over these slots because the material's already been removed. So I am actually going to turn off my rest material because I want one uninterrupted cut going in a circle. Then we'll jump down here to our cut parameters. Everything in here should be the same. We just want to make sure that our stock to leave on the walls and the floor is set to 0. Then we'll jump down here into the depth cuts. We really don't have to worry about any depth cuts here, so we can turn this off. And then we'll jump down here into our linking parameters. Inside of linking parameters, always make sure that we are reading absolute, 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 absolute. Top of stock is a little off. It's still recognizing the stock material, so we'll click on that. And we do want to select on this top edge so that it registers as 0. And then the depth, we'll click on that. It's still reading 0, but we want it to register this first step or the first circle. So we'll click on that, and we do have a value of negative 0.09375. So once we have all these parameters set up, we can go ahead and hit the green check mark, and we can see that we've created this nice circular toolpath that's spiraling to the center of our part. So I'm happy with how that looks. Why don't we just use what we've learned in the past and just copy and paste toolpath and just make some slight changes in our parameters? So I'm going to make sure that I just have this 2D dynamic mill selected and not any other toolpaths, because if I see a check mark next to them and I go to copy and paste it, I will copy those other toolpaths. So we're just going to select this last toolpath in our operations manager. We'll right click on it, we'll get this drop down menu, and we're going to look for our copy option. Now we're going to look for our red arrow and make sure that that's beneath this 2D dynamic mill. And then we're going to right click to the right of that red arrow. So I'll right click. This is going to open up my drop down menu, and I'm going to look for my paste option. So we'll click paste, and we can see that we've now copied and pasted that 2D dynamic mill, the one with the circle and the spiral going all the way to the center of the part. So the last toolpath, the one that we just created, I want to make some changes in my parameters. So we'll double click on parameters, and this is going to open up my parameters window. So I'm just going to go up here to the top for my toolpath type, and inside of toolpath type, our machining region is currently linked to that wireframe circle we created, and that's just too wide for the circle that we want to do for this next step. So we're going to deselect this machining region. So we have remove selected machining chains. We'll select that icon right there. We currently have no machining regions selected, so we want to select machining regions. We want to make sure that we are picking from our solid chains and that we do only have our loops selected. So I'm going to select the next step here, which is going to be this circle. This is going to be our machining region. We'll hit the green check mark. We do want to maintain that we are machining this from the outside, and then we'll move down into our avoidance regions. And right now, this avoidance region is currently linked to this outside edge of the first circular step, which matches the machining region that we just set up. So if we didn't make any changes and we hit the green check mark right now, I don't think any toolpath would be generated because both of those chains are overlapping each other. So again, we do want to be down here in the avoidance regions, and we want to deselect or remove those selected avoidance chains. And then we do want to click on a new avoidance chain, so we'll select on that icon right there. And make sure that you are picking from those 3D solid chains, and then we are only choosing from loops. So what we're trying to effectively do right now is move this avoidance region here from this first circular step to the second circular step. So we want to click on this outside edge of that center hole. So we'll click on that outside edge, and we'll hit the green check mark. Alright, so we've set up our machining region to only look at that second circular step. We are approaching this cut from the outside, and our avoidance region is going to be that top or the outside edge of that center hole. So we've effectively copied and pasted this toolpath and just moved it up from the first circular step to the second circular step. And I just want to make mention again, we copied and pasted this toolpath, so we do have to make additional changes in our parameters because we are still pulling those old values. So we'll jump down here into our tool tab, and we want to make sure that we are using that 5/8 flat end mill. If you wanted to, you could change the size of this end mill, but I don't see any interferences here with our geometry, so we should be good to go with this bigger tool. However, this is a copied and pasted toolpath, so it is still remembering that note that we set before. So it's saying the 5/8 flat end mill first circle. So we want to change that word first here to second, so that when it gets posted out, we have that link to this toolpath. And then we're just going to jump down here into our linking parameters. And inside of linking parameters, we are still pulling absolute, 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 and absolute. However, our depth here is set to our negative 0.9375 value, which is that first circular step. So we want to move that up. We'll click on the depth here, and we are going to move it up from this edge here to this edge here. So you can click on the outside edge of that second circular step, and we're getting a value of negative 0.03125. And now that we've updated our machining region, we've changed our tool node as well as our linking parameter depths, I feel good about hitting the green check mark and letting this toolpath regenerate. So we'll hit the green check mark, and we can see that we've created that nice circular toolpath that we were looking at before. However, we've shrunk it down from the first circular step to that second circular step. So I'm pretty happy with both of these toolpaths. Let's see how all this looks in Verify. So I'll go over here into the left-hand side in my Operations Manager. I'm going to select my entire second operation. And let's go up here to the top of the window and find that half-pipe looking icon for Verify Selected Operations. And again, this is going to open up that secondary window for us. And I'm just going to let this play out. So I'll hit play down here. We can see that we have our face mill, our 2D dynamic mill, and then we came back and cleaned up both of those slots. And then we have that nice spiral toolpath that's going to the center of our part for both of these circular steps. And I hope that you can gain an appreciation for how powerful 2D dynamic mill is, because we basically used that toolpath over and over and over again, and we just made some slight changes in our parameters. So why don't we check this verified model against our master 3D model? We'll jump up here into our visibility tab. We can turn on our workpiece. That's going to be your master 3D model. And then we can toggle our stock so that we see through it transparently. And right now, I'm not seeing much of a difference between these two models. The only thing that we're missing are some of these holes, as well as this arrow that's pointing down. So I think we did a great job cleaning up most of this part using 2D dynamic mill, and we can move on into some of these finishing operations. So let's back out of Verify and we can start to look at those toolpaths. Alright, so as we've talked about before, we should try to keep our workspace organized. Right now I have all of my toolpaths from second operation visible, and I just want to toggle those off. So over here on the left-hand side, we still have our second operation selected from that verify command, so I should see a check mark next to every single one of these toolpaths. I'm just going to go to the top of the window, and right above the words Machine Group 1, I'm going to find these three little waves. I'm going to click on that to toggle my toolpath on or off. So I want to turn these off, and then I can also go down here and start to compress down some of these file folders for these other toolpaths. So I should have a nice clean workspace to go ahead and start looking at these drilling and finishing operations. So let's start by drilling a 250 hole to open up this locating pin at the top of our part. Again, we want to be here in our Toolpaths tab in the top ribbon, and then over here on the left-hand side, we want to be in the 2D gallery. So we can either expand this out by hitting the drop-down arrow, or we can choose the drilling icon from the top row. So I'll click on Drill, and this is going to open up my drilling properties bar, and I just want to select on that top edge of this 250 hole for that locating pin. I do see that it is a 250 diameter. I can hit the green check mark, and this is going to open up our parameters window. We'll jump down here into our tool tab, and we still have a 1/4 inch drill active in our tool library from first operation, so let's go ahead and select on that. And for our comment, we can say 0.250 drilled hole. Okay, and then we'll jump down here into our cut parameters. If we wanted to, we could hit this drop down menu and change it to peck drill. However, this isn't a super deep hole, so I think I can just leave this as drill counterbore. All right, and then I'll jump down here into my linking parameters, and we just want to make sure that we are still reading absolute, 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 and absolute. Top of stock is not going to be this 0.015625, and it's not even going to be 0 because this face here is actually below the Z0 position. So let's click on our top of stock, and we want to reassociate this to this top edge of this hole or the outside edge of this hole. So we'll click on that hole right there. We can see that we are below Z0 and that we're at a negative value of 0.09375. However, if we look down here at our depth, we are seeing the same value in both of these parameters, and that's because when we started the drilling feature, we actually clicked on that edge for this hole. So we will have to reassociate this depth here to the shoulder of the drill tip. So we'll click here on depth, and I can't see this right now, so I'll have to rotate my part just slightly until I can see that shoulder there at the bottom of the hole. I'll click on that shoulder, and I can see that we have a depth value of negative 0.65625. All right, and as a good double check, let's make sure that our tip comp is on. So we'll come down here to tip comp. We do want to have that selected or turned on, but our breakthrough amount, we don't want to break through anything because we're trying to go to a blind hole depth. So we're going to change this value to 0, and then just double check your tool library and see what your tip angles are. By default, it's going to be 118 degrees, but our tool library, all of our drills are 130 degrees. So I'm going to change this value to 130 degrees, and then we can see what this looks like when we hit the green check mark. All right, so we have our 250 hole out there for our locating pin. Let's go ahead and move into our next detail, which is going to be the center hole. And even though that we don't see the threads here, we do have it called out in the blueprint that it's a 3/8 16th thread. And the minor diameter of that is actually going to be 5/16, so I'm going to open this up with a 5/16 drill. Now we're just going to follow the exact same workflow that we did before. So up here in the top left-hand corner in our 2D gallery, we can hit the drop-down menu, or we can find the drill icon from the top menu. So click on drill. We'll select on the top or the outside edge of that hole. We can see that that is a 312 diameter, so we'll hit the green check mark. This is going to open up our parameters window. We'll just jump down here into our tools tab, and we'll see that we don't have a 5/16 drill currently available in our tool library, so we will have to add that here from select tool library. We'll just keep scrolling down here from this window until we see a value in our diameter column for 312, and that's going to be our 5/16 drill, or tool number 137. So we'll hit the green check mark. That'll get populated here in our tool library. Just make sure that you click on that. And then we'll say our comment here is going to be 0.3125 drilled hole. Okay, so then we'll just jump down here to our cut parameters. And as I've said before, we can just leave this as a standard drill counterbore. However, I do want to show you what that peck drill detail looks like. So you can hit the drop down menu here and we can find peck drill. And then our peck depth value is just going to be set to 0.125 or an 1/8 inch every time that we peck that drill down. So then we'll just jump down here to our linking parameters. Here inside our linking parameters, make sure that this is set to absolute, 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 and absolute. We will have to reassociate our top of stock and our depth, so go ahead and click on top of stock. We're going to reset this value here to the top edge of that hole. And then our depth here is still reading 0 because that was the edge that we selected when we started our drilling feature. So we're going to have to click on depth here and reassociate that to the shoulder edge of that drill tip. So click down there at the bottom, and we can see that we have a value of negative 5/8. Now, one thing I want to mention before we move forward is this retract detail. And whenever we activate our peck drilling, we are going to peck drill down a depth in sequence that we set up. So before we set that up to an 1/8 inch. So every time that we peck down an 1/8 inch, we are going to have to retract out. And that retract value is right here. So right now we're set to a 1/2 inch absolute, which means that every time that we peck down an 1/8 inch, we're going to move that tool out a 1/2 inch above the part before we move down to that next 1/8 inch. So in theory, you could set this to incremental and change this to a smaller value, like an 1/8 inch. So you go peck down an 1/8 inch, retract up an 1/8 inch, go down an 1/8 inch, retract up an 1/8 inch, and so on. But I think that we can still set this to absolute because I'd like to have those chips evacuate. So I'm just going to change this retract value to something smaller. So I'll make this 0.125 so that every time that we peck down an eighth inch, we still are going to go above the top of the part, but we're just at a smaller value, so an eighth inch. Just keep that in mind whenever we're doing peck drilling because you could have that retract value set to stock or standard where it's like a half inch or 1 inch above the part. And then as a good double check, let's just make sure that we have our tip comp on. So I'll go to the tip comp tab right below linking parameters. And then we want to make sure that that tip comp is activated and the breakthrough amount is set to 0 because this is a blind hole. And the tip angle is matching what you have in your tool library. Like I said, by default, this would be 118 degrees, but in our tool library, we have 130 degree drill tips. So we'll hit the green check mark and see how that regenerates. All right, so it looks like we have that 312 peck drill at the center of our part. And I just want to check this out in backplot to make sure that we are retracting out that correct value. So let's move our model a little bit so it's easier to see, and I'll shift this to the center of my screen. And then I just want to have that peck drill selected from the left-hand side of my operations manager, and then we'll go to the top of the window and look for those three little waves for backplot selected operations. Click on that icon, we can see the tool simulate out there in the viewport, and we'll hit the play button from the top left. So this is going to be our clearance distance, and then once we hit the part, we're going to start peck drilling down that eighth inch. But every time that we hit an eighth inch, we're going to retract out absolute eighth inch above the part. And again, this allows for those chips to evacuate, so we're kind of pulling those chips with us as we retract out. And then once we hit the bottom of this hole, we're just going to retract all the way out there to that clearance distance, and that's going to be your peck drilling operation. So let's back out a backplot, and we can take a look at putting an edge break on both of these holes. So I'll click X on this window, and as we mentioned in the last video, we have the option to do a model chamfer or a chamfer drill. My preference with holes is to use that chamfer drill, so we're going to follow that exact same workflow from that video. So up here in the top left-hand corner, we're going to hit the drop-down menu to expand this gallery, and we're going to look for an icon called chamfer drill. It's going to be here in the hole making section. It's the first row and the second icon over. We'll click on chamfer drill. And now we just want to pick on the top edges of the holes that we just drilled. So that's going to be the center 312 drill, so I'll click right there, as well as that 250 hole for the locating pin. Now, we do have the option to include some of these drilled holes that are coming through from first operation. For example, we have this 400 through hole as well as this 250 through hole, but I think that these holes are a little bit too close to the surface here, and it's going to cause that drill to collide with that edge. So I want to show you a bad example and how to use check collisions to our advantage. Now, I only want to select on two of these holes because I will be deleting these entities later. So I'll come over here to that 400 through hole, and then I'll also select that 250 through hole. So over here on the left-hand side, we should see our center hole for 312. We should see that locating pin for 250, and then we have that 400 and 250 hole that are coming through from first operation. Let's click the green check mark. This is going to open up our parameters window. We'll just jump down here into the tool tab. We still have that tool library active from first operation, so I can select that half-inch spot drill. It's going to be tool number 24. And the comment here is just going to be chamfer drill. All right. I'll just jump down here into my cut parameters. I still should have the same settings active, so my depth here is going to be 15 thousandths, which means that we're going to put a 15 thousandths chamfer on each one of these edges. We'll just jump down here into our linking parameters. Inside of linking parameters, make sure that we are reading absolute and absolute. The top of stock should be 0 because it's registering from that edge that we just selected. So let's take a look at this check collisions option here inside the linking parameters. There's an illustration of a drill, and right beneath that there is an icon here for check collisions. So click on that icon, and this is going to open up a miniature backplot for you. And as I select through some of these entries here from this top window, I can actually simulate that chamfer drill moving from one hole to another. So I'll click on this first entry, which is going to be that 312 hole. I can see that there are no collisions. I'll click on the next entry, which is going to be the 250 locating pin. Once again, there are going to be no collisions. And then I'll start to move into these through holes that are coming through from first operation. I'll click on that 400 size hole. And we can see that that drill is getting pretty close to these edges. However, we still do have clearance, and I do not have any collisions active. But when we jump down here into that 250 hole, I can clearly see that the drill is colliding with this edge, even though that it says that there are no collisions. So you can see that this is a great way for us to double check our selections and ensure that we will not collide or crash with the part. So I will be removing that 400 size through hole as well as that 250 size through hole. So over here in the top left hand corner inside this window, I'll select that 400 size through hole, right click on it, and then I can delete it. And then I'll select on that 250 size through hole, right click on it, and delete it. And that's going to update our selections. We'll go ahead and hit the green check mark, and then we can hit the green check mark once again to generate that toolpath. So let's move into chamfering the rest of our part so that we have no sharp edges for someone to cut themselves on. We're going to use that model chamfer feature like we did in the first video. So again, we're just going to follow the same workflow. At the top left-hand corner, we're going to go into our 2D gallery. We can hit the drop-down menu to expand this out. And we're going to look for an icon called Model Chamfer. That's going to be on the third row, third icon over, Model Chamfer. Click on that icon, and this is going to open up your parameters window. Now again, I don't know why by default it just doesn't have you start chaining geometry, so you will have to go over to the right side of this window. Click on Select Chains, and we only want to be selecting from loops. If you have faces selected, deselect that. We'll pick the top edge of this first circular step, and we want to make sure that we are going around clockwise so that we are climb milling. And then we'll also select the top edge of the shoulder. This will give us some issues later, but I want to show you how we can troubleshoot this. So click on that top edge, and we can see that it is going around clockwise for climb milling. We'll hit the green check mark, and then we'll just jump down here into our tool tab. We still have this tool library active from first operation, so we want to pick on that 1/2 inch chamfer mill, which is going to be tool number 319. I'll put a note here for chamfer edges, and then I'll jump down here into my cut parameters. I should still have the same settings, so we want to make sure that we are putting a 15 thousandths chamfer, and we can leave that bottom offset as 50 thousandths. We don't want to make any changes to depth cuts. If we go over here to lead in, lead out, we want to make sure that that is activated. And then we'll jump down here to our linking parameters. And this does not give us an option to set absolute, absolute, absolute. However, this is going to rely on those edges that we selected. So we can hit the green check mark and generate this toolpath. Alright, so as I said before, I knew clicking on that top edge of the shoulder was going to cause some issues. So we will have to troubleshoot this so our toolpath isn't interrupted. And the reason why this is happening is because we're using a 1/2 inch chamfer mill. And as we're coming around this edge, we are going to collide with the sidewall of the circular extrusion. So we could do one of two things. We can try to use a smaller chamfer mill, and that could work if we bring it all the way down to like an 1/8 inch. However, I want to show you another option, and that's to use a ball mill to chamfer edges we can't reach. So let's update the parameters of this chamfer mill to remove that edge that's currently being interrupted by that circular surface. So jump over here into the left-hand side in our operations manager. We'll find our model chamfer. We'll click on parameters. We'll open up the parameters window. And then over here in the toolpath type at the top of that window, we are going to rechain this geometry. So I can remove selected chains, and then I'm going to rechain this, and I'm only going to select this top edge of that circular step. So we'll hit the green check mark. And now we'll hit the green check mark once again, and you can see that we're only chamfering that circular step. Now, the reason why we couldn't just update that toolpath to use a ball mill instead of a chamfer mill is because whenever you use model chamfer, it will only allow you to use chamfer mills. If you try to use any different tool, it's going to give you an error and it won't generate the toolpath. Instead, we're going to use the contour mill to try to project this ball mill. So up here in the top left-hand corner in our 2D gallery, we're going to have to hit the drop-down menu to expand this, and we're going to look for our contour option. So click on contour, and we want to make sure that we are selecting from 3D solids, and that we're only selecting loops. So I'm going to select on that top edge of that shoulder so that we are going around in a clockwise fashion for climb milling. And then I also want to select on these holes that we couldn't clean up with the chamfer drill earlier. So instead of clicking on these holes one by one, I'm just going to hold down the Control key on my keyboard as well as the Shift key on my keyboard, and while holding those two keys down, I'm going to double click on the top edge of one of these holes. So I'll double click on the top of this 250 hole, and you can see that I can pick up all of the holes on that surface. However, the arrows are currently going the wrong way. We are doing an internal cut, so this is actually opposite of climb milling. This is conventional cutting. So I need to reverse this so that these arrows are going in the opposite direction. Down here in the chaining window, I'm just going to click on these two arrows going opposite directions. We'll click on reverse. And now we can see that our cutting direction is going counterclockwise for these holes, which is climb cutting on an internal surface. So let's go ahead and hit the green check mark. This is going to open up our parameters window. We'll just jump down here into our tool tab. We don't have a ball mill currently active in our tool library, so I will have to go to my select tool library. And then I'm going to filter this out so that I'm only looking for ball mills. So we'll go over here to filter. I'm going to find my second icon for End Mill 2 sphere. So that's going to be our ball mill. And then we're also going to deselect our engraving tool. We'll hit the green check mark. And you can see here we have all these different ball mills. I'm going to look for the 1/8 ball mill, which is going to be tool number 304. And then we'll click the green check mark. We can see that that tool got added to our tool library. Just make sure that you select on that. And then we also leave a note here for ball mill chamfer. And then we'll just jump down here into our cut parameters. Our compensation type is currently off. This is remembering from when we were trying to do our engraving. So I want to turn this back on. We'll hit the drop down menu and we'll just update this to computer. Additionally, by default, our contour type is set to 2D. However, when we're trying to do chamfers, we do have to update this. So we'll hit the drop down menu and we'll change this to 2D chamfer. And it looks like the toolpath is recognizing that we are trying to use a ball mill. So I just need to update my chamfer width and my depth. So let's think about this as a 45-degree chamfer. So both of these values should read the exact same. So I'll update my width here to 0.015, and then the depth should also be that 0.015 or 15 thousandths. And then we'll jump over here into our lead in and lead out. We can turn that on because we aren't doing an engraving, so we're not going to cause any collisions while we're trying to cut this chamfer. And then we'll jump down into our linking parameters, make sure that we are reading absolute, 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 and absolute. Top of stock, we can update that to the top edge of that shoulder. So if I click on top of stock, I'll just click on one of these edges here for that shoulder, and I'm getting a value of negative 0.53975. And you'll notice that the top of the stock and the depth are going to read exactly the same. We've already set up the chamfer depth and the chamfer width back here in cut parameters, and you can see that there as 15 thousandths. So let's hit the green check mark and see how this regenerates. And that looks like a huge improvement from what we were looking at earlier with the model chamfer. None of our toolpaths are being interrupted by the sidewall of that circular surface, and we can even reach down into these holes that we were previously hitting with the chamfer drill. So let's see what this looks like in Verify. I'm going to jump over here into the left-hand side of my Operations Manager, and I'm going to select my entire second operation, so I see a check mark next to every single one of those toolpaths. Then I'm going to go up here to the top of the window and find that half-pipe looking icon for Verify Selected Operations. We'll click on that. And this is going to open up that secondary window for us, and we can see our stock model as well as our master 3D model beneath it. I'm just going to toggle this through so I turn off my workpiece, and then I want to make my stock model completely opaque. So we'll hit play and let this run out, and I'm just focused on seeing how these edge breaks worked out for us. So we can see that we cleaned up both of these holes here using a chamfer drill, and then we hit the entire outside edge of this first circular step using a model chamfer or that chamfer mill. And then we even cleaned up that shoulder there, as well as these deep holes that we were previously hitting with the chamfer drill using a ball mill without colliding on the sidewall of this circular surface. So let's take a look at our last two details, which is going to be adding this arrow here at the bottom of the part, as well as threading this 3/8 by 16 hole. So I'm going to back out of Verify, close this window. So let's start by cleaning up our Operations Manager. We've been working on quite a few toolpaths, and we have all these different folders opened up right now. So I'm just going to close these or collapse these down so that I have some space here to add more toolpath. And then we still have our entire second operation highlighted or turned on because we were just looking at it in Verify. So as long as your second operation is selected, we're just going to click on the three waves right here above Machine Group to toggle off our toolpaths. And then we're going to engrave this arrow here at the bottom of our part, and we're going to follow the exact same workflow we used to engrave the text on the backside for first operation. So up here in the top left in our 2D gallery, we can hit the drop-down menu and expand out this menu, or we can choose Contour here from that top row. So we'll click Contour, and then we do want to be selecting here from 3D solid chains, and we only want to be selecting with loops. I'm just going to select this arrow, and it doesn't really matter which direction that we're going. We're just going to be engraving here. So hit the green check mark, and then we'll jump down here into the tools, and we want to find our engraving tool, which was that 1/4" engraver that we used in first operation. That's tool number 374, and we'll just say engrave arrow for our note, and then we'll jump down here into our cut parameters. And we do have to toggle this back because we were using contour for chamfers before. So we're going to change our compensation type to off. So we'll hit the drop down menu and change this to off. And then our contour type, we do have to change it back to 2D. So we'll hit the drop down menu for 2D chamfer and change that to 2D. Here inside of lead in and lead out, we do have to turn that off because we don't want those tails to be following with this engraving. So we'll turn lead in and lead out off. And then we'll jump down here into our linking parameters, and we do want to make sure that this is reading absolute, 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 and absolute. Top of stock, we do have to update, so we'll click top of stock, and we'll just click on the top edge of that arrow. So we do see that that is negative 0.09375. And then for this depth, we can go like 10 thousandths lower, so if I wanted to, I can just go ahead and say minus 0.01 here from this value, and that would put that depth of that cut about 10 thousandths below that surface. And if you wanted to, you could actually change this to incremental for this one instance. You could say incremental, and you could say minus 0.01, and that would also put that 10 thousandths below this surface that we established for top of stock. So let's go ahead and hit the green check mark and let that regenerate. We can see that we are engraving that arrow there. And now we're going to move into our last toolpath, which is just going to be adding a 3/8 by 16 threaded hole here for that center detail. Now, as a disclaimer, the default tool library that we're using doesn't have a lot of options for threaded mills, so we do have to create a new tool to be used for our threading toolpath. And that should be relatively easy as long as we have all the dimensions. So we're just going to jump up here into our tool manager located in our toolpaths tab. So click on tool manager, and this is going to open up your tool library window. Now, this top area of the window are going to be all the active tools in your part or your current tool library. This bottom area of the window can be set up to be an entire tool library, so like all of your tools on your shop floor, and then you can pick and choose what tools that you want to include in a specific machine. So right now, I just want to add a tool in this specific machine, so I'm going to right-click in the top area of this window, and then I'm going to select Create Tool from that drop-down menu. So this is going to allow you to create a tool for your tool library, and we have all these different options from flat end mills to bowl end mills to ball end mills, so on and so forth. But we're going to look for an icon called thread mill. So this is going to be in the fourth row and the third icon over. So we'll select thread mill, we'll hit next, and now we can start to establish some dimensions or geometry for that tool that we're creating. Now we are going to be working here in UNF threads, and as I mentioned before, we're going to be using a 3/8 by 16 thread, which means that we have 16 threads per inch. So down where it says threads per inch, we're going to update this from 20 to 16. So now that we have 16 threads per inch, and the outside diameter, we're going to make this a little bit smaller than the actual thread size. So this isn't going to be like 0.375 or 3/8. And we want to make this even smaller than the minor diameter, which was the 3/12 hole or the 5/16 hole that we drilled earlier. So I want to change this outside diameter here to 0.3. So I'm a little bit smaller than that minor diameter, so I can plunge that tool inside of that hole. The overall length we can leave the same. However, the cutting length, we want to limit this to 1 tooth. So right now we have cutting length of 1 inch, and that would mean that we have 16 threads in that 1 inch. So I'm going to change this here to 1 divided by 16, and then I'll click on one of these other boxes so that I can calculate out. So I'm only trying to create 1 tooth, so that's going to be 0.0625. Now we can hit next, and this is going to pull us into our finalized properties tab. So if I wanted to, I can change my tool number, and we think back to our default mill library, we had 446 tools, so I don't want to accidentally overwrite one of those tools, so I'll make this 447. If I click on the next box here, it's actually going to populate the next 3 fields here with that 447th tool. And if I wanted to, I could set up my speeds and feeds. So every time that I pull this tool from the tool library, it will always pick these default values. I'm not going to make any changes here, so I'll just hit finish. And we can see that we've populated our tool library with that tool. So now that I'm done adding tools and I don't want to make any more changes, I just want to save my tool library. So I'm going to hit the green check mark from the bottom right corner of this window. So I'll go down here, hit the green check mark, and that'll save my tool library. So now that when I choose a different tool path, I can pull from that tool library, which is now going to include that threaded mill. So from the top left-hand corner, we're going to go to our 2D gallery. We'll hit the drop-down menu to expand this out, and we're going to look for an icon called threaded mill. And this is going to be in the hole making section. It's going to be the second row and the second icon over. We'll click on thread mill. And this is going to operate exactly like a drilled feature where I can select on edges of holes or diameters. So I just want to click on the top edge of the center hole here, and I can see that that value is 0.3125. We'll hit the green check mark. This will open up your parameters window. We'll just come down here to our tool tab, and we're going to look for that threaded mill that we just added to our tool library. So here in our tool library, we're just going to keep scrolling down until we find that 447th tool. So we'll click on that. That's going to be your 300 thread mill. And here inside this comment, I'm just going to say thread mill, and then I'm going to say 3, 8, 16. And then we'll jump over here into our cut parameters tab. And inside of cut parameters, what we're saying is the number of active teeth is equivalent to 1. And that matches what we set up in our tool library when we created the tool. And the thread pitch here is going to be that 1 divided by 16, which is equivalent to 0.0625. And then we have to clarify if this is going to be an inner diameter thread or an outer diameter thread. So this is a blind hole at the center of the part, so it's going to be an ID thread. Now, one thing that I like to do whenever using a thread mill is actually to override the geometry diameter. And that's because I want to control the major and the minor diameters. So I'll click both of these tick boxes on. And the major thread diameter is going to be that 3/8 or that 0.375. However, we want to account for some slop because the bolt itself is also going to be 3/8 or 0.375. So I'm actually going to say 0.375 plus 0.01. So I'm giving myself 10 thousandths of slop from side to side so that bolt can fit in. And then the override minor diameter, that's actually going to be our tapped hole, which is that 3/12 hole at the center of the piece. So this is going to be 0.3125, and that's going to set up your major and your minor thread diameters for this 3/8 by 16 hole. Next, we want to make sure that this is set to right-handed thread, and then below that, our machining direction, this is actually going to be a little bit confusing. So if we were doing top to bottom, this would be an outside thread or an OD thread. However, for an ID thread, this is going to be the bottom to top, because we're actually going to try to climb mill from the inside, so everything is reversed. So this is going to be a bottom to top thread. We'll start at the bottom of the hole, and then we'll thread out. Next, we'll jump down into our lead in and lead out. Usually this is on by default, but if you did want to control your exit and your entry arcs and angles, you can do so. From here, we'll move down into our linking parameters, and we just want to make sure that this is reading absolute, 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 and absolute. We can turn our clearance on if we want, and this is one of those instances where I want to change it from like 5 inches to 2 inches, and we'll also make that absolute. Next, we'll take a look at our top of thread. We'll click on top of thread, and we want to link that to the top edge of that 3/12 hole, so we'll click on that top edge right there. We are seeing that this is registering as 0, so we're all good. Move down here into our thread depth, and we want to link that to the shoulder of that drill tip. So click on thread depth here, and I just have to rotate my part slightly so that I can see the bottom edge of that hole. We'll click on that shoulder, and we're seeing a value of negative 0.625 or 5/8. All right, so it looks like we have everything filled out here in our thread mill, and we can go ahead and hit the green check mark and see how this regenerates. All right, so it looks like we have that nice spiral toolpath for this thread mill operation, and I just want to see what this looks like in backplot. So let's move our part slightly, and then I can center this in the middle of my screen. And then I'll make sure that I have my thread mill selected here on the left-hand side in my operations manager, and I'll move to the top of the window and find those 3 little waves. We'll click on that, and we can see that our thread mill is being generated out here in the viewport. And something to keep in the back of your mind while this is running is when we created this tool in our tool library or tool manager, we set this up so that it was only going to be 1 tooth, or 1 divided by 16 for that 3/8 by 16 thread, which was a pitch of 0.0625. And that's going to be represented here in yellow. So let's move to the top left of the window and we'll hit play. And then as this tool is plunging down, I want you to remember that we set this up so it has an OD of 300 thousandths, which is slightly smaller than the minor diameter of the thread or that 3/12 tapped hole. That way we can move all the way down to the bottom, and then once we reach that shoulder, we can start to spiral out, which is going to be that climb cut function for this 3/8 by 16 thread mill. And then we'll retract out, and that looks really good for my thread mill. So we'll back out of backplot, we can take a look at our entire program and verify. So I'll click X on this window, and then we just want to move over here into the left-hand side in our operations manager, and I'm going to select the entire Toolpath group for second operation. So click on that, and we should see a check mark next to each one of these toolpaths. Then we'll move up here to the top of the window and find that half pipe looking icon for verify. We'll click on that. And once again, this is going to open up that secondary window for us. And I'm just going to let this play out to see the results of our toolpaths. So we'll come down here and hit play. And we can see that we have all of our dynamic mills. We did our circular steps. We have our drills as well as all of our edge breaks. And we even came back and engraved this arrow down here. And we finished up with that 3/8 by 16 thread at the center of the part. So I don't think there's anything else that we can do here in second operation. I'm going to say this is complete. So I'll back out of verify and we can save the model. And that's going to finish up our complex second operation program for the Soft Riser A-1 3D model. I hope you enjoyed my explanation of all these toolpaths. Thanks for watching, and I'll catch you in the next one. Bye.